let me just erase this, guys, and then we will continue with the other methods. Okay, so this was the naive model, and now let's just switch our attention to moving average model, which is a little bit more complex, and then we will talk about the forecasting with moving data, moving average. That's why it is called. But let me just erase this first. I will give you guys more insights about this procedure, this method. Guys, moving average, it uses an average of specified number of the past actual values. For example, well, let me just introduce everything, and then we will talk about with the talk with the examples. So each observation in the data receives the same weight. Okay, let's say if you have, let's say, 5 months, trailing 5 months, or past 5 months, we give them each weight 20% weight, which is the importance of each data, and then we are going to move the data with a specified structure. How? We will see how it is in a second, but before that, let me just show you the equation. Let me just walk you through the equation, and then we're going to see an example. Guys, the main equation for the moving average model is this right here. Moving average forecast is equal to activity in previous n periods over n. N is the number of periods in a specified forecasting time frame. Okay, activity in previous n periods could be activity, could be ADR, could be expense, could be RevPAR, could be everything. It's the variable itself, and of course the n is the number of periods in a specified time frame, in a specified average time frame. So take a look at this example, because talking about this without an example is doesn't make sense. So take a look at the example over here, guys, and let's analyze this, and then everything will be fine. So Home Sweet Home Hotel, let me just scroll down a little bit. Okay, Home Sweet Home Hotel acquired the 6-week time series data for the number of rooms sold below. If you remember, time series data is the data that deals with the time given in the question or in the case. So we have over here, we have 2 different columns. On the left column we have number of weeks, and then we have number of rooms sold. So 1, 2, 3, 4, 5, 6 weeks we have, and then the corresponding number of rooms sold. For the first week we sold 210. For the 4th week we sold 400 rooms. So what we're gonna do, guys, based on the given table, let me just clean this. Based on this given table right here, the question becomes what is the 3-week moving average in number of rooms sold for Home Sweet Home Hotel? Guys, 3-week moving average is the specified term. It could be 2-day moving average. It could be 5-week moving average, meaning based on the specification right here, we are going to go back 1, 2, 3 periods in our given timeline. So we have 3 weeks, we have weeks over here, and we are trying to find out the average number of rooms sold for the Home Sweet Home Hotel for the 7th week, okay, based on a 3-week moving average. So we're gonna go back 3 weeks in our timeline, in our table, and then we're gonna use all these numbers, okay, to come up with the forecasting for the week number 7. This is exactly called moving average, because when it moves based on a specified average structure, based on a specified structure. So our specified structure is here is the 3-week moving average. Take a look at how we solve this. Let me just clean this real quick, and then I will show you how to solve this question. So we're going to utilize its main equation, guys. Let's just remember ourselves the main equation. Moving average forecast is equal to activity in previous n periods over n. N is the number of periods in a specified term, meaning we are dealing with 3-week moving average, MA, let's say. That means we are going to go back 3 weeks in our historical data, okay? Therefore, this becomes our N in the solutions. So activity number of periods will cover data for week number 6, week number 5, week number 4. If we go back up, as I told you guys before, we are going to go back 3-week period in our table, and then we're going to use those numbers to come up with the forecast using the moving average model. So that's exactly what it is. So what I have over here, guys, since I'm dealing with 3-week moving average, my n will be 3, okay? And of course, activity in this case will be number of rooms sold. This is the variable. So 110, 150, 400. I'm going to plug in those numbers. I'm going to do the division. I will have 220 rooms forecasted to be sold for the next week, which is the 7th week. So it's easy that is. This is called moving average. But again, in the moving average calculations, all we have to pay attention is the specified periods. It could be 3-week moving average, it could be 2-day moving average, it could be 2-year moving average, meaning it will specify the periods that you have to incorporate in the forecasting calculations. Again, if it's 4-week, for example, we're going to go back 4 weeks and take plug in those corresponding numbers in the activity. Activity is the variable we are forecasting. Okay, guys? So the trick is over here. Please read what I'm going to highlight. As new financial results come in, they will be added to the moving average calculations. For example, what we did, we had 7-week data, and we have corresponding numbers over here. We forecasted this number week 7, but whenever the actual new data comes in, for example, actual number 7 data comes in, let me just do this so I can show you. Okay, the earlier specified with the 3-week moving average. Okay, the earlier data, I'm sorry guys. The earlier data will be dropped. For example, to forecast week number 7, what we did, we incorporated week number 6, 5, and 4. But now we have, let me just use this. Now we have the actual data for week number 7. And then imagine that we are trying to forecast week number 8. What we're going to do, guys, we are going to drop week number 3 over here. In a 3-week moving average, we're going to incorporate number 5, 6, and 7 this time, meaning whenever the new actual data comes in, we are going to drop the earliest one, which is number 3 in this case, and we are going to include the newest one. That is called moving average. Literally, it moves. And remember, forecasting requires a constant revision, so whenever we have the actual data, we will have to move our forecasting for the next periods. And the structure, moving average structure, is exactly what I just show you right now over here, guys. Okay, it moves with the new actual data. Let's analyze the situation. Let me just clean my screen. Let's analyze the situation to see how it works with the new actual data. Imagine that the new financial data, we're going to utilize the home sweet home example again. And imagine that the new financial results have just came in for the home sweet home hotel, and the actual number of rooms sold is 300 for the 7th week. Remember, our forecast was 220 in the previous home sweet home example, but now the actual data is actually 300 right now. What are we going to do? What is the moving average forecast in number of rooms forecast for the 8th week? So we are trying to find the 8th week right now. In this case, remember, we are going to drop week number 3. We're going to incorporate week number 4, week number 5. I apologize. We're going to drop week number 4, actually. We're going to incorporate week number 5, 6, and 7, because we have 3-week moving average to find out what week 8 is. Okay, guys? So take a look at this. This is my explanation. What I just told you right now is over here. So let me take a look at this. You can see our solution. This is our solution right here. So the number of rooms sold for the week number 8 will be week number 7 actual data, week number 6 actual data, week number 5 actual data over number 3, because we are dealing with a 3-week moving average. Therefore, 186.66 rounded up to 187 will be the forecasted number of rooms for the week number 8. Again, whenever the week number 8 data comes in, we're going to drop week number 5. We're going to include 6, 7, and 8. We're going to keep going like this, and that exactly defines the moving average. Okay, guys? So this average is often considered to be reliable than naive models because it moves and it gives weights, it gives importance, equal importance to every single data point in our time series framework, okay? Remember, naive models, it does not include time series, which is a time factor. It just includes one forecasting assumption. That is why this method is much more accurate. The only reason is that it gives an equal weight to each data observation, data points we have, and of course it includes the most recent data and drop the most removed one. If you remember, trying to forecast the removed periods is difficult, therefore it includes the newest operational figures in the assumption, guys, okay? That is exactly why this is better than naive models. A little bit complex, but we have more complex one. It is the exponential smoothing model, guys. Exponential smoothing model is the most complex forecasting approach we're gonna see in this lecture video, in our lecture, and then let's just tap into that area right now. Exponential smoothing models, guys, it is the exponential forecasting, meaning it factors in different factors that we don't see actually. What we don't see it because it is hard to control for, let's say, million different variables. Let's say, I don't know, travel patterns to Europe, travel patterns to China, okay? It is hard to control that. Instead of trying to figure out and include every single variable in the world, in the entire hospitality and tourism world, we are using a smoothing constant because this model is based on weighting the most recent data. We are going to weigh the most recent data, meaning we are going to give more importance to most recent data, and then we're going to utilize smoothing constant, which is a constant number. It's just a number, let's say 0.55, okay, 1.10, I don't know, 0.60. We're going to utilize a number to control for other variables which are not seen in the equation, but we are going to control for them, okay? This model is a weighted average calculation with weights, which is the importance of every single data. It declines if the data becomes older because this model, just like moving average, deals with the most recent and new data. Therefore, the weights will decline if the data gets older. For example, you have day number 1, and then we are at date number 45 right now. Day number 45 is 80% important, okay? But day number 1, as we approach day number 45, let's say 2% importance. But it was 80% important in our data set. That's why that's exactly what exponential smoothing is. It exponentially grows, new data grows, and it gives more importance. It gives weights. That's exactly what it is. And then we are going to utilize this concept in our calculations along with a smoothing constant, because as you know, smoothing constant is just a constant number that we incorporate in our equations that controls for different factors in the forecasting or in the world, okay? This model is mostly used for short-term forecast because it yields more accurate results, because just like moving average, it includes the new data. Therefore, for long-term periods, which is also most difficult forecasting procedures, because most difficult periods are difficult. We talked about this at the beginning of our lecture. So therefore, we are trying to come up with actually short-term forecasting, and this is a great tool to utilize for short-term forecasting. Guys, we have to have, in order for us to perform an exponential smoothing forecasting, we have to have the forecast from the 2 previous periods and the actual data from the 2 previous periods. So we're going to incorporate 2 immediate previous periods, and we have to know both forecasted amount from the 2 previous periods and the actual data from the 2 previous periods, okay? Guys, the main notion of this forecasting is also that if the forecast for the particular period was too high, reduce it for the next period. If it's just too low, raise it. This is one of the most important focus or approach or assumption or the notion of an exponential smoothing. Before I show you the exponential smoothing equation, guys, we have to talk about smoothing constant a little bit more, okay? Guys, you know smoothing constant is just a number like 0.50, 1.10, or 0.60 that we utilize to control for different factors in our forecasting because we don't incorporate them, we don't see them, but we actually incorporate them by using the smoothing constant. So smoothing constant equation, before I show you the exponential smoothing equation, is just like this. Take a look. Smoothing constant is equal to forecast in the most current period minus forecast in the prior period over actual observation in the prior period minus forecast in the prior period. Remember, we have to have prior period, two data from prior period, forecasted data and the actual data from the prior period, and then we have to have the current period, let's say CP, okay, and we have to have the forecasted data from the current for the current period and the actual data for the current period, and then we have to have SC, smoothing constant. We're going to combine them together. This sets the exponential smoothing formula. Okay, guys? So this is the structure we are dealing with, and of course, smoothing constant, it has its own equation, and we just talked about this right now. So we're going to incorporate every single thing in our exponential smoothing formula. Therefore, the exponential smoothing formula becomes just like this. Take a look at, guys. My forecast based on the exponential smoothing is equal to forecast in the most current period plus, in brackets, smoothing constant, there we go, multiply by actual observation in the most current period minus forecast in the most current period, guys, okay? So this is the main equation we will have to deal with actually, but again, if the smoothing constant is not given in the question, we will have to calculate that first, and then we are going to calculate the forecast based on exponential smoothing. Why? Because if you take a look at over here, we have to have the smoothing constant in our equation, guys, okay? Let me just clean everything, and then let's just take a look at this question, and then let's deal with how this works, and then we will, the concept will be much more easier to understand. Okay, guys? Take a look. William N is the example right now, and then let's analyze what's going on over here. As I told you guys before, it is always a good idea to list what's given to you in the question so you can visualize the question better, so your solution will be accurate, will be correct. The management of William is estimated to generate $150,000 and $165,000 in room revenues for July and August, respectively, by using some other forecasting methods. So, look, in July and August, there are two different time frames over here. They estimated, forecasted, don't forget, forecasted that, okay, forecast, let's use F as a notation, $155,000, okay, and $165,000 in room revenues, all right? But and then they use some other forecasting methods. Then the actual data showed that $155,000 and $180,000 in room revenues for July and August respectively. So actual, let's notate that as A, $155,000. That was the actual result, and it was $180,000 for August room revenues. Well, however, CEO of the firm wishes to compare the estimations with exponential smoothing, because let's say they are not happy with the results or they like to double check the results. Therefore, what is the forecasting room revenue in September based on the exponential smoothing forecasting model? So they are trying to come up with the September values based on this, guys, based on this structure right here. The first question you should ask yourself before you solve for the question, because if you take a look at the smoothing, if you take a look at the exponential smoothing formula, okay, this is the exponential smoothing formula over here, okay. The first thing you have to ask, if you have smoothing constant or not. So let's go back to the question right here. Do you have a smoothing constant given in the question? No smoothing constant. Therefore, what we have to do in order for us to forecast September, we have to find smoothing constant first, This is the first part. And then we're going to deal with the exponential forecasting as the second step. Okay, guys? So smoothing constant is not given in the question. Therefore, we will have to calculate the smoothing constant first. Take a look at this part of the lecture right now, guys. Okay? Smoothing constant formula is given as from here to here. Okay? Well, here. This is the smoothing constant formula. All right? So we have forecast in the most current period. Yes, forecast in the most current period, $165,000. Forecast in the prior period, $150,000. Over actual observation in prior period, $155,000. Minus forecast in the prior period, forecast in the prior period, $150,000. 165 minus 150 over 155 minus 150. 3 is just an integer, it's just a number, becomes our smoothing constant. Now, we got the smoothing constant, so we are done with the first step. The second step is the actual forecasting based on exponential smoothing formula, okay? And we know the formula now. We can run the formula based on what we have in the structure for the William N, okay? So my forecast will be equal to forecast in the most current period plus, in brackets, smoothing constant multiplied by actual observation in the most current period minus the forecast in the most current period. So forecast in the most current period, $165,000. August, most current period, because we are trying to forecast September. Smoothing constant, boom, right here, 3.003. We have that. Multiplied by actual observation in the most current period, $180,000. We have that as well. Minus forecast in the most current period, $165,000. We have that as well. So when we plug in the numbers, guys, we can do that simple math because we are done with plugging the numbers. $165,000 plus, first brackets, we know that, okay? And then the first parentheses, then whatever we have in the bracket, then the outside one. So 3 multiplied by $180,000 multiplied by $165,000. When I do the math right here, guys, $210,000 becomes the forecasted total room revenue for height in based on exponential smoothing. So it is complex a little bit, but again, it is the most accurate among the three of them we have talked so far, we have discussed so far, okay? There are some implications of this smoothing constant model. So take a look at over here. Let me just erase that, okay? Let me just erase this first thing. Okay. There are some implications of the smoothing constant model, guys. The implications are here. Calculated smoothing constant will be small if sales and hence revenues have a relatively stable in the past period, okay? Smoothing constant will be small if you have a relatively stable revenues, which is kind of good for you guys. On the contrary, it will be large if the firms are experiencing an increase in demand and rapid growth. Usually brand newish firms, brand newish establishments, they do have the higher values of smoothing constant because they are just new and then they are growing rapidly. They are investing in their operations rapidly. That's why, okay? Guys, the casual models, we have only one over here. Let me talk about what they are. This is where we are right now. Let me talk about what they are. Casual models are just the models based on the associations in forecasting assignment. What does that mean? I will tell you. That's why they are called associated models. So casual models deal with different types of variables, okay? And those different types of variables, and those variables are based on the associations in the forecasting environment, meaning, okay, they are dependent on each other, meaning some of the variables are driven by and independent variables, independently moving variables, meaning this. We are forecasting a variable, okay? We are forecasting a variable, let's say ADR. ADR, it is what is forecasted, therefore, ADR becomes a dependent variable. Why do we call dependent variable? The answer is that ADR, let's say ADR, ADR right here becomes our dependent variable because ADR, which is our dependent variable, is dependent on occupancy percentage, let's say. I'm just making that up right now, okay? Occupancy percentage. And that ADR also depend on, I don't know, sales volume, okay? and ADR depends on customer traffic, and ADR depends on individual income levels. Let's say, I'm just making that up right now. So if ADR depends on a whole bunch of stuff right here, that the right side of the equation, my right, your left, so the right side of the equation becomes independent variables. Therefore, dependent variable, which is the ADR, is driven by the independent variables in the equation. That is why there is an association over here, there's a relationship over here. That is why causal models are also called associative models. Okay, guys? That is why our forecast depends on this equation. That's exactly what it is, and this is the causal models. So we just talked that causal model, we only have one causal model to discuss. Usually, simple regression analysis, simple regressions or multiple regressions are the mostly utilized causal models in the industry, guys, okay? So regression analysis over here is the causal model we're gonna talk about, and then in this analysis we are gonna involve dependent and independent variables, and then we are gonna estimate the forecast based on the relationship between dependent and independent variables, guys, okay? So we're gonna do this, and then this is, so we can look at this example right now. Well, before the example, actually, let me just talk about the equation, and let me just talk about the regression analysis itself. Guys, we talked about this. The forecasted event is dependent variable. DV, dependent variable, is the forecasted event. We talked about this. And then the forecasted event, which is the dependent variable, is driven by whole bunch of IVs, independent variables, okay? So dependent variable and independent variables are the issue over here, are the core of this regression analysis, and then we're going to take a look at their association, their relationship. Therefore, my forecast equation will be written just like this based on the regression analysis. Forecast y is the dependent variable, will be equal to A plus B multiplied by X. A is the products or goods provided for the unexpected conditions, like walk-ins, non-checked-in guests, etc. Okay, and the B represents average goods or services provided per each checked-in guest, and therefore X is the average number of guests in the hotel. So I'm just going to tell you this one more time. Y is the dependent variable, which is the forecasted event. A is the products or goods provided for the unexpected conditions, like walk-ins or non-checked-in guests. B multiplied by X. B represents average products or goods provided per each guest in check, and X, of course, the average number of guests. So this is the explanation of the main equation for regression analysis forecast. And then let's just see a Pink Palace results as an example to see how it works. And then this will be the final portion of our lecture for today, okay? Pink Palace. The management of Pink Palace Resorts forecasted that, on average, 4,000 rooms will be sold for the next period. 4,000 rooms. Great. With an average occupancy of 1.5 people per room, 1.5 people per room. Also, the management projected that 1.45 meals will be needed for each checked-in guest. Look, each checked-in guest, 1.45 meals, like number of plates on average, of course, for each checked-in guests, okay? However, 410 people are not checked in into any room. They will also be included in the forecast. This is what we have so far, 410. Let's say walk-ins, or 410 people. They are in the hotel. They are in the your establishment. In your establishment. However, they are not checked in. They are not staying in the hotel, but they are using the hotel amenities. Let's say. What is the forecasted number of meals? Forecasted number of meals to be sold for the Pink Palace Resort for the next period based on the regression analysis. The question is clear. We are going to perform a regression analysis based on what is given to us right here, guys. Remember, in our solution, our forecast, which is y, is equal to A plus B multiplied by X. What are we solving for? number of meals. So number of meals is the forecasted event, which is dependent variable. Dependent variable is based on all these, which are the independent variables. Okay, that's my equation right here. All right. So forecasted number of meals is equal to, okay, A. What is A? Okay, let's go ahead and remember ourselves. The products or goods provided for the unexpected conditions. Unexpected conditions are the checked-in, the walk-ins over here, non-checked-in guests. Therefore, in our equation, in our solution, 410 will be the A over here, guys. 410, okay? Put it that way. Plus B multiplied by X. What is B? Take a look at this. Let's go back and then let's see what B is. B represents average products or goods provided per each checked-in guest. Average products or goods provided for each checked-in guests. Guys, the trick is here. What do you think what B is? Each, products and average products and goods provided for each checked-in guests. How many guests we checked in? We have to find it out, okay? For each checked-in guest, we are providing 1.45 meals. Okay, guys? Because if you take a look at back again, let me show you one more time, represents each products and goods provided per each checked-in guest. Average number of guests. Okay, guys? So 1.45 becomes B in this case because we have 1.45 meals, which are the products for each checked-in guest. Check mark over here. And X is the average number of guests. How are we going to find average number of guests? How am I going to find it out? Is that, take a look, if I am selling 4,000 rooms and if I am filling each room with 1.5 people, this will be my X. Therefore, my X will be multiplied by 1.5 multiplied by 4,000, okay, multiplied by 4,000 because this portion is X. Let me just, this portion is X because, okay, number of average number of average number of people is I have 1.5 people for each room on average, and I'm selling 4,000 rooms. This is the X by itself. Therefore, I am set. So this is how I find the average number of people in our property. So when I do the equation, guys, of course multiplications are first. When I do the equation, I need 9,110 meals on average, meal plates, burger plates, pizza plates, you name it, on average for each checked-in guest, and let me just back up, for each guest in the property. So this is how we forecast number of meals, number of guests, RevPAR, revenues, expenses, number of people, number of walk-ins, you name it, in our operations. This is how we forecast based on a regression analysis. Okay, guys? So, guys, this finalizes our lecture today. I hope you enjoyed it. And then please don't forget to check your course schedule for the upcoming lecture. If you have any questions, please reach me out by email or send me an email so we can discuss by email as well. Okay. Please try to stay on top of everything. Take a look at the course schedule. Take a look at the upcoming deadlines, and I will see you guys in the next video for the chapter 8. Until then, have a great day, and I will see you guys in the next lecture video. Thank you.